Good morning to all. In today's lecture series, we are going to see about what is that Prim's algorithm. So before going into the Prim's algorithm, first we have to know about what is a minimum spanning tree. So the spanning tree is a subset of a graph G which has all the vertices covered with minimum possible number of edges. Hence, the spanning tree does not have a cycles and it cannot be disconnected. So, this is the definition of the minimum spanning tree. So, the definition of the spanning tree. So, the spanning tree is nothing but it is a subset of a graph G which has all the vertices should be connected and it should not contain any cycle. For example, consider the given graph A, B, C. So, what are all the possible spanning tree for the given graph is we have a three set of spanning tree in the given graph. So the applications of spanning tree mainly we are used in the network planning and computer network routing protocol and cluster analysis. We are using the spanning tree concept. So what is a minimum spanning tree? In a weighted graph, minimum spanning tree is a spanning tree that has a minimum weight than all other spanning trees of the same graph. So for a given graph, we have a multiple spanning tree. So in that multiple spanning tree, which one has the minimum weight, that spanning tree is called it as a minimum spanning tree. So the minimum spanning tree is a spanning tree that has a minimum weight than all other spanning tree of a given graph. For example, consider the given graph that contains the four vertices 1, 2, 3, 4. That is a weighted graph. So from that weighted graph we have to find out the minimum spanning tree. Means to find the minimum spanning tree for the given graph we have a two types of algorithm. One is a Prim's algorithm, other one is a Kruskal's algorithm. So what is a Prim's and Kruskal's means? That is used to find the minimum spanning tree for the given graph. For the given above graph, we have to find out that three spanning tree. So what is a spanning tree? It is a connected edges of all the vertices and it should not form the cycles. So for the three possible spanning tree, we have to find the cost. Cost is the sum of all the weight of the given vertices. So in that three spanning tree, which one has the cost is very minimum means that is the minimum spanning tree of the given graph. So the third one is the minimum spanning tree of the given graph. So that could be find out if suppose our vertices is 3 or 4. Suppose number of vertices is more than 8 and 7 means we cannot find it manually. So we go it for to find that as a using an algorithm we can find the minimum spanning tree, that is a Prim's and Kruskal's. So what is a Prim's means? The steps for implementing the Prim's algorithm. First, initialize the minimum spanning tree with the vertex chosen at random. So we can choose any vertex as a random. So find all the edges that connect the tree to a new vertices and find the minimum and add it to the tree. So first find the random vertex and find all the edges that connect the tree to a new vertices and find the minimum and add it to the tree. Keep the step, repeat the step until we get the minimum spanning tree. For example, for the given graph, we have to find the subgraph. Subgraph means it should connect all the vertices, should be connected, it should not form the no cycles. First choose any one vertex as a random. For example, choose it as an A. From A, find the adjacent of A. So from that adjacent vertices, which one has the minimum edge means, minimum weight means go to that vertex. So in that graph we have at from A we have a D, B and F vertices. From that A to D the weight is 4. From A to B the weight is 2 and A to F the weight is 5. From that A to B weight is very minimum, so select that vertex. So from that vertex B again select the adjacent. From the adjacent select the minimum one and add it to the tree. So repeat the steps until we visited all the vertices. So through that for doing that visiting vertices, we should not form any circle. That is should be considered in the minimum spanning tree. From that B, which one has the minimum is from B to D, that is the minimum edge, so go to D, and from the D we have a several edges. From the D we have a B and E, so B is already visited, so visit E with a weight of 2. Next from B we have a adjacent of C, G and F, so the next visited vertices is minimum of B to G, so select that G as a minimum. So after that from G, another adjacent vertices from the G's are F and C. From that F and C, which one is the minimum? F. So go to that vertex F and add it to the tree, and through to that visiting time we should not form a cycle. Next, find out all the vertices are visited. Only the unvisited vertices are C. So from G we have to find out adjacent of C, either E, B and G. From G to C we have a minimum weight, so add that edge for the given tree. So this is the final minimum spanning tree for the given graph, and to find the minimum spanning tree is equal, minimum spanning tree means in the cost of connecting all the edges is 2 plus 1 plus 1 5, then 16. So this is the weight for the given graph. So this is the procedure to find the minimum spanning tree for the given graph. So what is the procedure? First, select any vertex as a random. From the random vertex, find out the adjacent vertices whose adjacent have the minimum weight, mean add that vertex to the tree. Next, we find the adjacent of another that second vertices. So this process to be repeated until we visited all the vertices. So it is the procedure for the minimum Prim's, using the Prim's algorithm. This is the procedure.